fatalities in our nation deal with a DUI. So if you were able to eliminate that altogether, you're talking about a lot of lives saved. So will be interesting what the federal government comes up with on that. Emphasis areas, I brought those up. These are areas that we focus on. These are areas that the data tells us to focus on. So when we pull up our crashes and start looking at them, they fit into a lot of these areas. Traffic fatalities, even though we've had reduction in VMTs over the past couple of years, our fatalities have increased, which is not something that initially when the pandemic started that I was anticipating. I was hoping to see reductions across the board, but unfortunately that's not what we saw. Intersection, the state of Georgia alone, this is one of our main emphasis areas. This is not somewhere where we lead the nation as a positive thing in terms of having crashes and fatalities and serious injuries at our intersections. So this is an area that we spend a lot of time and effort in. Roadway and lane departure is another big one. This accounts for, I think, 30% of our fatalities for the state is in that one area. And there's very simple countermeasures that you can look at, including your rumble strips and your cable barriers. So what is a crash? What does it look like? What do we even talk about? So it comes down to a CABCO. Some states use a fatal injury and then a non-injury. We, as in Georgia, we adopted the CABCO severity. So K means you're fatal, A means you're serious injury. So that means you're going to the hospital because something is seriously wrong. B is a minor injury, so that could be a gash in the leg or something that the officer sees, but it's nothing intense enough to go to the hospital about. C is your complaint in your neck, nothing visible that you can see, and an O is your property damage only. And these type of crash severities are dependent on one really main parameter is speed. As you can see down and below, this actually comes from, it came from Vision Zero, but it actually comes from an ITE document. The difference between the chances of you surviving a crash when you're a pedestrian in a vehicle, when you're at 20 miles per hour, there's a 10% chance that you will die in that crash. But when you go increase that by 20 miles per hour, that chance increases up to 80% by 20 miles per hour. So speed is definitely a big factor, which I'll get into quickly here. Minor collision. So what type of crashes do you look at? Rear end angles, or you can have your left through, your right turn angle, side swipe opposite direction, side swipe same direction. Not a collision vehicle that has a whole bunch of stuff wrapped into it, but you have your pedestrian, bicycle, scooter, animal, roadway departure. One of the most severe, that's your head on. Conflict points. So the name of the game for safety is reduce as many conflict points as you can. And you should be making the intersection or the roadway safer. This actually depicts the total conflict points for a full access facility. You have 32 conflict points. When you start looking, roundabout reduces it down to 8. So 8 different ways that you can get to a crash with another vehicle or person or whatever the case may be. So 32 to 8 is a big jump. That's why roundabouts are being pushed so hard as a safety countermeasure. And it boils down to, and I'm stressing that our research community here in Georgia starts looking at these different things. This is something actually comes from Dr. Blair Turner from Australia. But the kinetic energy in a crash goes back to the speeds associated, the ways that you hit people in terms of the manner of collision. But the top end, you can see that's a signalized 4-leg intersection. The more dissipation you see in that graph is the higher amount of energy that comes into the crash, so higher severity. Down below is a roundabout, so you have control of speed on those approaches, and you can see the kinetic energy is more centralized, so a lot less of an impact to go along with that. So how do we select projects? Well, Kelly's going to go into a lot more detail into that, but high level, use crash modification factors. There's a database that the federal government has. You go check out the database in terms of what solution that you're trying to come up with, and it actually will give you a crash modification or a crash reduction number, and use that to be able to figure out how many correctable crashes can you actually reduce. We're almost there. We've gone to either side of the spectrum here, so this is actually pretty good. Yeah, that's good. That's good. That's good. But yeah, so crash modification factors, these are proven through research of being able to correct a certain subset. Be careful though, because you really need to read into the details. You can get tripped up because you could look at realigning a road, but that study may be only for a rural approach with a certain amount of vehicles actually going through it. So make sure you pay attention to those type of things. Hotspot, systemic, and systematic. So these are really big buzzwords too in the safety world. The main difference between them, hotspot is you're looking, you found a location that has a lot of crashes. It's a little bit more passive in your approach, but people say you're kind of chasing your tail in that sense, or you're chasing fatalities in a sense. Hotspot, that's kind of where you're getting that from. You're finding locations because there's a bunch of crashes there, and then you're going to try to correct that. So there's not too much predictive measures going into it. Systemic is we understand certain characteristics that cause these crashes. How do we correct those? So a great systemic type project could be rumble strips. And you go out and you put rumble strips everywhere. They work. They're a proven safety countermeasure. You should see reductions in crashes across the board. So then knowing those characteristics, knowing a countermeasure, so you're going wide scale with that, it's more systemic. Systematic means that we're doing it just because it's proven and it's being done without no one really thinking about it behind the scenes. Backplates is a good example of that from a traffic signal perspective. At one time, they weren't used as much. Now they're used across the board, especially with the reflectivity tape on the back end of it. So that's just something that's done every time we look at a traffic signal. There's many other systemic type measures. Rumble strips is another good one. Cable barrier is another good one as well. So to look at this, FHWA does have proven safety countermeasures. These are all measures that have research behind them and they're proven to work. So that you don't, in terms of providing that justification in writing a report, there's not a whole lot that you really have to go into in terms of that justification because it's proven. FHWA says so, so it's great. We can move forward with it, right? But no, I mean, seriously, these kind of measures are extremely worthy in terms of being able to correct a good amount of crashes depending on what areas you look at. I highly recommend you go check out the website below. They have great fact sheets breaking everything down. So looking at a project, what do we want to see and how do we build that within the safety program? So we identify a safety concern. We'll get into that. Crash screenings go into ICE. You go through a traffic engineering study, concept design, letting, construction, and evaluate and approve. Vast majority of the safety projects follow this template. There are ways that we try to cut down on this to deliver projects faster. So you don't always have to have a concept report. You can jump straight into design. And your traffic engineering study maybe doesn't have to be as comprehensive because of what type of measure that you're looking at. So we try to cut down on that as much as possible. So identifying a safety concern comes from a lot of different ways, but the way that it's done most often is a data-driven approach. How do we identify that concern? Now, there's other ways that they can definitely be looked at as well. The districts are a strong partner. They let us know because they see stuff out in the field that we don't get to see from the state office level. Politicians, upper management, going through road safety audits, internal reviews as well. What's the tool that we use? Well, Numetric, I mentioned it above. There's going to be a lot of other workshops coming up in terms of Numetrics. I'm not going to go into a great detail, but this is a great way in terms of finding where you need to be looking in for crash perspective. You can go through a lot of different filters. And then this one, I just wanted to highlight the filters that I use the most is route type. So you can choose between state routes, local routes, city routes, county roads. You can do functional class. So a lot of times I'll eliminate interstates if I don't want to look at the interstates. And you can also filter it down by districts, counties, cities, MPOs. So it's vast in what it can do. You can also rank things in terms of using our sliding window application. So this is actually City of Atlanta. This is actually looking at pedestrians and took out the interstate, and we can rank it by crash severity or crash rate. So again, very powerful in what we're able to look at. And next I'll have Kelly come up and she'll talk about the crash screening process.
Thank you. All right. So as Sam said, he kind of walked through Numetric a little bit, which is how we kind of identify our locations. So now what do we do with it and how do we determine what we should do at that location? So we have what's called a crash screening. We have a template and it kind of outlines all of these different sections of data that we want to hit and review in order to determine the best possible alternative for the intersection. So here's an example of one that was completed. As you can see, you have a nice photo of the intersection and a blurb with some information. So the biggest things is we look for other projects in the area. We also try to look for as many traffic volumes using all the available resources that we have. And then we also come up with a crash diagram. So the way this is set up, the sections are such that you get as much information from all of the available resources from this kind of preliminary data source. So we understand that none of this is truly accurate. As you can see from the first photo, we have just GIS right-of-way lines. But I'm sure as everyone in the room understands, impacting right-of-way can significantly impact the project. So that's something we want to look at even in this preliminary phase, understanding that, we'll need to further evaluate that down the road. So yeah, other projects volumes are the things that we look at. So the biggest thing is crashes. So this is the standard template that we like to use. As you can see, it shows the manner of severity and that CABCO scale that was referenced. And then it also shows the trends over the years. So this is really important because it can show, well, is there a certain manner of collision? Is that maybe not increasing in frequency, but maybe it's increasing in severity. So we want to look at both things, both frequency and severity. How is that being impacted over time? Something else that's important with these tables is that we want to mark them out if there's been like a signal upgrade, or maybe there was another project that was there. We want to see how that construction impact that location. So we would break that out and show that in the table. And so then the second table on the bottom just further breaks out those angle crashes. So, okay, it's an angle, but what are people actually doing at the intersection? Are people turning left? What are the movements associated with those crashes? And that way we can try to tie that to a geometric concern with the intersection and target that as an improvement. So another thing with safety, as we were talking about, was kinetic energy in crashes. So a lot of our projects do with traffic calming. So we also like to look at speed. So we take probe data, probe speed data. So again, we take this with a grain of salt. It's not accurate. It tends to underreport, but it's a good gauge. So we know if they're already over the posted speed, that means they're probably really speeding, and that's something we need to look at. So again, just using engineering judgment to just kind of excuse me, just using engineering judgment to make the best justification for the proposed countermeasure. So this is where it kind of all comes together. All those sections that we've seen before, we put up the benefits. Okay, what is this gonna do? So we've seen that we have a ton of angle crashes, and so people are also speeding. So a multi-lane roundabout will remove those left turn conflict points, as well as provide some traffic calming into the intersection. So really just using that data-driven safety justification. So again, we'll also lay out some of our concerns, and these concerns also help us estimate our cost. So we are a benefit cost-driven program. So certain impacts can impact which alternative that we're looking at. So maybe a roundabout has some really significant impacts on a gas station in a corner. And there's also a park, there's certain design constraints that prohibit certain alternatives. So this is just kind of making sure that we've hit all of the things we'd like to look at: right of way, volumes, speeds, and then just try to come up with the best safety alternative that we can. So the template I just walked through was for an intersection base. So we've also expanded that to a corridor, which will also look at more connectivity and more corridor-based projects. So after we've done our screening, we say, yep, this looks like a good candidate for a potential safety funded project. Let's further evaluate that. So we'll go ahead and collect our official counts, and we'll do an ICE. I'm sure many of you are familiar with ICE. So our stage one, a lot of this, what you'll see in the ICE, has already been set up through our screening. So we've already looked at the potential alternatives given the crash history. So based on your screening, your crash screening, your alternative screening for your stage one should be pretty easy. And then similarly with your stage 2, this is kind of where you're incorporating all of that operational analysis with accounts you've collected, putting some more refined cost and all of that good stuff. All right, so then once we have confirmed the control that we want to implement with the ICE, we'll move on to a traffic engineering study. And so this just goes through and heavily documents everything that we've written. And this also goes on to get signed by the district and our office. So it's an official signed document. And then it'll go on and get incorporated into the concept report. And that is following the traditional PDP process. But I guess as Sam said earlier, you know, we do try and look for ways to cut down on our process. So we do have some alternative delivery mechanisms. We'll implement things through quick response if possible, other things like that. And so then finally, we go on and actually get it designed, let, and go on to construction. So we'll definitely develop a concept layout, look at all of that. And so this is where your roundabout design guide that I'm sure many of you were interested in comes into play. So yeah, I guess in terms of design, it is an ever progressing progress. So once things are down and out in the field, we like to evaluate them and see what design practices we can make better, what is working, what's not, how can we make it better. So it doesn't just start once you've, or the process doesn't just stop once you've selected your alternative. We like to continue to evaluate and improve. And I'm sure you guys have seen some differences in our principles in our roundabout design guide. So that's kind of a traditional how you build a safety project. We also have some other things that we do within our safety program called a road safety audit. So we have guidelines and templates. This is an FHWA guideline. We perform 14 road safety audits a year, 2 per district. And these are corridors that are selected based on a data-driven process. So again, similar to New Metric, this is a sliding window analysis. We'll select corridors up to about 1 mile in length. And we'll, excuse me, using our data-driven process, understand the crashes that are going on there. And then we'll go through kind of a more in-depth way to actually develop a project. So we'll assemble a multidisciplinary team comprised of people at GDOT, not just the TMC, but also the district maintenance office, MPOs, regional commissions. We'll look at the corridor. If there's a hospital or an elementary school, we'll get some of their representatives involved. We're trying to get the people who really use those roadways every day to give their safety input back. All right, so similarly to our process, we're going to use data and everything. So before we actually go out and walk the corridor like we do in the road safety audit, we'll collect some background data, understand what's going on at every intersection, what are the turning movements, all the crashes, so that we're prepared when we go out in the field and can answer questions from our team. So that's all compiled into recommendations, which are then distributed out to all stakeholders. So these are written in a way such that anyone who's never seen the document can just pick this up and understand what's going on, where exactly the location they're referring to, and what to do. So when it comes to, installing a new advanced warning sign, we have not just install the advanced warning sign, how many feet back from a reference point is that, at what intersection, and things like that. So we just want it to be as detailed as possible. And then all of that, all of our data analysis, the field visit, our recommendations are compiled and distributed in a final report. And of course, it doesn't stop there, but we actually have to make sure that our recommendations are implemented. So we do have a tracking system to where we can look and make sure that we're staying on top of these RSA recommendations. All right, so we have another twist on the RSAs, which is called Safe Routes to School. Sam mentioned that it is being expanded into high school, but it was previously looking at only elementary and middle school. So they look at how kids get to school. So one thing that I thought was really interesting that they do is called Take a Knee. So we all use the intersections every day, but what does it look like from a kid's perspective to take a knee? And it looks very different. So that's something that they look at, and how to walk and bike safely to school. So something else we have is called a local road safety plan. We are currently in our third pilot program with FHWA. Little background on this program, I think 83% of the roadways in Georgia are maintained locally, and 42% of our fatalities are occurring on those roadways. So FHWA is encouraging us to look at where our fatalities are happening across the board, not just on system. So this is an opportunity to encourage locals to write their own plans and basically identify and leverage safety funding, as well as some other DIY things such as enforcement, education, things like that. All right, so coming back to our takeaways, the biggest thing is crash severity and manner of collision. We want to understand how the collision happened in order to prevent it in the future. And then in terms of analytics, we use new metrics to identify our hotspot locations and rank and prioritize them. And then in terms of innovations, we have crash templates, which really just help document and encourage that engineering judgment. I think we said that we were going to do questions at the end of the second presentation. Is that correct? Okay, so I'll just
any burning question, we can have one or two. If not, we can save them for the end. Thank you. Thank you. Yeah, we can. Thank you. That was a great overview of the whole process, and that was really helpful. Let's see. Well, it's going to the second presentation. Your mouse is doesn't like my hand. Let's see. Okay, over here. So our next presentation is, let's see, practical and innovative CFI or DLT considerations. Hopefully it comes up soon. All right, here we go. So a speaker for this presentation is Anju at Waiwa. Anju is Georgia Tech graduate with 20 years of experience in transportation. Anju worked for the City of Roswell Transportation Department for 7 years and served as project manager on multiple improvement projects, as well as the city traffic city traffic engineer. He joined KCI Technologies in September of 2019, and he is traffic engineering practice leader. So with that, let's welcome Anju.
All right, thank you, Christy. Glad to be here with you this afternoon. Welcome to the workshop. So wanted to speak to you today about some practical, innovative CFI considerations. You're following along with the theme of learning things. The first lesson for you today is that Georgia DOT would like us to call them DLT intersections, displaced left turns. But we're all very familiar with the CFI terminology. So with that, our agenda includes talking about 2 intersections currently in operation and some lessons learned from 2 DLTs in operation in Georgia. Also talk about some concept design experience that I've been involved with and KCI has on the State Route 124 corridor. Some alternatives analysis considerations for those of you who are looking at these from both a traffic perspective and then a roadway design perspective. So before I get any farther, I did not come up with all the materials, so I wanted to share thank you to some of the KCI, CEI staff who gave us some material. Also, Tom Sievert, Gwinnett County, and Scott Zingraf and Chris Raymond with GDOT provided some input. So our first, Georgia's first DLT intersection was constructed and opened in 2017 in Dawson County. This is at the intersection of State Route 400, which is a limited access, primarily limited access freeway, State Route 53, and that replaced a 4-leg signalized intersection. Here's an aerial view of that location. State Route 400 is kind of in that north-south direction. And the CFI DLT provided for in the northbound direction and southbound direction, displacing those left turns. So they have that crossover intersection prior to the main intersection of State Route 53. And then on the State Route 53 approaches, you have right turns, call them right turn slip lanes, that then allow you to turn onto 400. And so this is operating very well. It provides a lot of capacity at this location. Primarily, I believe this was intended for a capacity improvement, not really addressing a safety concern. But one interesting thing, which I've come across in evaluating a lot of intersections, comparing with other alternative intersections, is the CFI can really move a lot of traffic when you orient them with that left turn, addressing a high left turn movement. Here's a drone footage looking north along State Route 400. You can see the 2-lane crossover heading in the northbound direction. And then, so raise a hand, who has driven through this CFI? Okay, great. Most of the crowd here. And so this was designed by Georgia DOT, first one installed, and this is taken, I guess, right near the end of construction. So in terms of signal operation, there's one signal controller operating all of those intersections. There's a lot of signal overlaps to make that operate. And so Georgia DOT traffic operations spearheaded the timing at this location. And there are many phasing considerations and lengthy tweaking of timing to progress the traffic through those intersections. During construction, they had to address the skewed right turn signals. So if you were turning off of 53, you come up to this very skewed angle, and the red signal heads were visible from the through lanes. So they added louvers to limit that visibility from the through traffic. You'll notice here in this picture, and I'll touch on it in a minute, these right turns were designed as dual rights, which they did actually change to a single right. So it's striped as a single right lane, and the right turns are allowed on red, which helps because the right turn volume is fairly low. So here's a picture of that, actually back right near the end of construction, where they changed that 2-lane approach to a single lane. So, and then some observations. If you are traveling north, for instance, and you've made that crossover movement, and now you're about to turn left on the State Route 53, that's the angle that this picture is taken from. You'll notice that southbound 400, they have a right turn lane onto 53. That's actually a yield controlled situation, and something to be mindful of or think about as you're designing the CFIs is whether maybe that right turn lane should be signal controlled, because you're turning right and you're not necessarily looking directly opposite you as someone who's going to turn left and they've got a signal operation. So that's something that to consider in these designs. Also, the pedestrian phase. So it's a very wide intersection, State Route 400. As a pedestrian, there's very few here at this location, but you would have to cross basically 3 travel flows of travel. So, and the way that's currently timed is you have the same concurrent time as State Route 53. So if you start on one side, you would have to make it all the way across, or potentially you might get stopped in the middle and then have to continue. So in some locations, if you have more pedestrians, you may want to do some type of two-stage crossing. There, consideration for the pedestrians. Another consideration at the CFIs is to be cognizant of some properties will have reduced access. So right-of-way was not required for McDonald's, which is on the one of the quadrants with the right turn lane. However, access was changed to that business. There were actually 4 lawsuits from retail users at this interchange. And I know that McDonald's was awarded damages because their access was changed. However, they weren't part of the right-of-way negotiation. So we need to be mindful of that. GDOT's now, addressing that in future CFIs. From our CEI staff, they oversaw the construction of this. And from day one, they said many drivers kept trying to turn left at the main intersection. So the contractor had to have one traffic control person staged at that main intersection, directing drivers not to turn left until they eventually learned, and the signage was all up to not turn at that location. They also said it was difficult to maintain and keep the fast food driveways open during construction. They did close driveways for a couple days, but as they were building that, switching traffic over, it was a little difficult. Also, they had a standard provision which for daytime lane closures were not allowed. That made it a bit difficult to construct. They said even if they could have lane closures for just limited times during the day, that would have greatly helped in the construction. So this one was, CFDLT was constructed in 2017, and we've got some time here to do a comparison of the crashes. So just doing an initial crash review for the 3 years, year 2013 to 15, prior to construction, prior to opening, we had 266 total crashes. And you can see here the severity. Primarily, we had property damage only, the O type. We had some possible injury and minor injury. And then in terms of manner of collision, primarily we had rear end crashes. There were a total of 23 angle crashes at this location. So the power of numerics is you can quickly pull for the 3 years after. So from 2018 to 2020, we had a reduction in crashes. We had 185. And you can see that the severity, primarily it's property damage only. We did have a couple serious and 1 fatality. And then in terms of manner of collision, they pretty much stayed consistent. Still had a lot of the rear ends, which is common at our traffic signals. We did have additional rear angle crashes. So we had a total of 32 angle crashes, and did look at just the 1 fatality and the 2 serious injuries. And those were one of the serious injury and one of the fatalities was at the crossover intersection. So it's somebody running the red light, unfortunately. And then one of the serious injuries was a rear end on 400. But overall, we are seeing a reduction in the crashes. And then in terms of volume, so these were collected in 2019, pre-COVID, and this intersection is carrying a pretty high volume, but not as high as you'll see some of the future locations later in the presentation. So this operates at level of service C during the peak hours. And you'll see our heaviest left turn movement is 361 in that northbound direction. So moving on to our second DLT, which was opened in Georgia, was opened in city of Snellville. This opened in 2019 and replaced a 4-leg intersection. How many have driven through this CFI? All right. Here's a drone footage from at this location, pretty close to end of construction. Not quite all the markings are out there. You still see a few barrels. So this is looking eastbound on US 78. And State Route 124 is in that north and south direction. So at this location, every one of these is a little bit different. You'll notice we have the displaced left heading in the eastbound direction. So you've got two left turn lanes turning onto 124 north. Coming in the opposite direction, westbound, we've got a displaced left. So those are two lanes turning onto southbound 124. And then if you're coming south on 124, you have a single right turn lane, slip lane there. Now, what do you not see on State Route 124 north? There is no right turn slip lane. So that's actually a prohibited movement. And we'll talk about that in just a second, because the next slide shows how that right turn's not allowed and that left turn's not allowed on northbound State Route 124. So there is signage out there to prohibit those turns. And the reason why at this intersection those movements were prohibited is there's actually Henry Clara Boulevard, which provides that ability to get to eastbound US 78 or westbound US 78. So this is a previous signalized intersection with advanced signage to direct cars to their destination. Now, with the removal of these turn movements, there has created some confusion for drivers, and currently Gwinnett County is looking at some options for additional signage to really get drivers' attention that you need to turn prior to and avoid. One of their concerns is really that those drivers going north and trying to turn right that location, because they could turn directly into those oncoming cars that are coming left, making that left turn. And in terms of property access, so during construction, GDOT did purchase a number of properties along that slip lane and provided limited access so that they don't have that. So they've recognized that they were compensating property owners for that reduced access. So then switching over to some concept development work. KCI is currently designing the State Route 124 widening project in Gwinnett County. And we've evaluated displaced left turn at two high volume intersections. This is a very busy corridor, very commercial stretch of road with high traffic volumes. And it's currently 4 lanes and going to a 6-lane project. So at the intersection of 124 and Ronald Reagan Boulevard, this is your current 4-leg intersection. And we have very high volumes at this location. So we looked at a number of different alternatives. In Federal Highway, their technical brief says these DLT intersections provide great throughput when compared to conventional intersections, especially when you've got high through volumes and high left turn volumes. So I put up the traffic diagram here. Not sure if you can see that from your seat, but there is one approach which has very high left turns. The northbound, say Route 124, there's your AM and PM volumes. And so what we developed at this location was a one-sided CFI. So instead of having the need to provide 2 legs of a CFI, it's just addressing that one high volume left turn movement. We have a dual left crossover, and then they were turned on to Ronald Reagan Boulevard. And then there's a very high right turn movement. So we have 2 rights that come from Ronald Reagan Boulevard and then would merge back onto 124. That does require 3 displacements. So we're making sure to eliminate access and driveways on that quadrant. And one other thing to note is if you're coming south on 124, we've kept a single left turn there to accommodate a lower volume at that location. The second location along this corridor is up at Sugarloaf Parkway. So this is another major east-west crossing of State Route 124. It's currently a 4-leg intersection. You see the dual left turns there heading north on State Route 124. So here's the traffic diagram, and I'll try to quiz you here. Which left turn movement, and I can read them out in a second, would you look to have a displaced left turn first? We've got, so on Sugarloaf, heading in, what we're showing here is up. We've got 290 AM lefts, 160 in the PM. Heading north on State Route 124, we've got 345 in the AM and 580 in the PM. Heading east or south on this diagram in Sugarloaf Parkway, we've got 70 AM and 85 left turns. And then on this other direction, if you're going south on 124, we've got 20 AM and 30 PM left turns. So which direction do you think we chose to look for displaced left? Yeah. 124 going north. All right. And then second question is, so, with alternative intersections, you're really looking to pull those left turns out of the intersection, gives you more capacity. So we came up with a second improvement. What is another approach you could maybe displace a left turn? Shout out an idea. I heard a south suggestion. All right, so what if we could move the 20 AM and the 30 PM to a different location and make them go past the intersection and U-turn and come back? So we combined a DLT with a median U-turn idea. So that in the northbound 124 direction, you've got your two lefts. We're handling that heavy left turn moving on Sugarloaf Parkway. And then by removing that southbound left turn signal phase at Sugarloaf, we're getting more green time to Sugarloaf and handling those 20 to 30 left turns in a U-turn situation. We've also, this has gone through and has an approved concept report. So in working with GDOT, we have limited access designated on those two parcels on that right turn slip lane location. Oh, one more thing to point out. Anything else you noticed on this that's different about the right turns?
There's no northbound right turn.
Well, this is a right turn. So there are right turn movements on all four approaches.
It's a add one.
Yes, so if you're coming off of Sugarloaf Parkway and you're turning right, we're basically giving you a free flow right turn because we're adding, and now we're getting the sixth lane going south. So that avoids a signal at that location and it'll handle a very high right turn volume. We wanted to show one concept of when you're working through alternatives analysis. We were looking at the intersection of Hammond Drive and Ashford Dunwoody, which is, as many of you know, very busy, very congested. And so don't hesitate to flip the idea of a CFI. So instead of the crossover happening before the signal, you could actually have it after the signal. So if you wanted to make the left turns in that northbound direction, make the left first, travel down, and then do a crossover to get to that other approach. This works good if you're like a constrained situation, or maybe you have some kind of constraint or railroad you're trying to cross to flip it. Now, in this location, when we did the capacity analysis, we found that the delayed reduction was not there. And really the reason was Hammond Drive and Ravinia, the volumes aren't similar to that northbound left turn movement. And so it wasn't found suitable at this location. Last slide is sharing, this is from Chris Raymond, showed that there are some DLTs in progress. And one is in Fayette at the intersection of State Route 54 and State Route 74. That's in PFPR. And then a second location is in Douglas County at State Route 5 and then State Route 6. That's in concept. And I know with each of these, they're also looking at other alternatives before they select, see if DLT is the preferred alternative. So that finishes my presentation. Thank you.
All right, thank you very much, Angie. That was great. So we have some time for question and answer today. So does anyone have any question?
Yes.
And for the Steel 53400 DLT, I know that started out as with lawsuits. I'll look back to see.
So what I have heard is nothing official on that or, you know, in-depth look at that, but I have heard, yeah, sort of some questions about the right-of-way cost and well, lawsuits, but you know, when you do compare it to a grade separated, you know, and maybe a time when we have more funding, you know, it might have been, maybe it's more considered. I think, you know, some of the, like that, I remember there was discussions many years ago about when CFIs first came to light, like where could we find a location for these? And I almost think that was sort of a pilot project. It was, hey, we have the right of way. Let's do it here. And then that opened up the opportunities for others ones. And even today, you know, you look at the volumes and you might say it doesn't really need a CFI. You could have done some other things. You could have added dual lefts. You could have added triple lefts, like now something in our toolbox. So I don't think anything's official that I've heard that kind of goes back and looked at, was that the best alternative?
Real quick, I actually don't think the right of way was that much more. That's why they picked the, but I'm real curious about the lawsuits, but I also have a question on the same intersection. On the rear ends, it seems really high rear ends, number one. They did decrease, it's still pretty high. Do you know enough about the data whether or not it was rear ends for people just both going through movements, car in front stopped, or is it caused by a person that got confused, wanted to make the left, suddenly realized they couldn't, and then get this rear end? I mean, those are two different types of crashes.
Sure. So Tom, haven't looked detailed at the crashes. That was kind of an initial just review for this presentation. And I did that actually at the suggestion of Scott Zengraf, because he said, hey, that would be interesting to see, you know, what is the before and after. So yeah, I think some more could be looked at in terms of how's that operating.
I wouldn't be surprised exactly what you said, like there probably is, especially when it first opened. Me and Andrew were actually having this conversation before in the last session, but I expected in the first year that you would see some of that. But those numbers, in terms of the high percentages for signalized intersections, at least in the metro area or more urban areas, that doesn't strike me as something out of the ordinary. Usually, the signalized intersections have a lot of rear ends, but the plus is that they're hopefully lesser in severity. And what Andrew showed in that graphic, it had a lot of PDO type crashes associated with it, but it is that you bring up an interesting point. I might have to dig into it with Andrew on that one.
I'm pretty interested in the reverse DLT you showed that concept of. One, correct me if I'm wrong, but that would mean that your left would run with the side street through to the opposing main line. And two, has one of those ever been built anywhere? It's pretty cool concept.
So I'm not aware of one being built. And I actually give credit to Todd DeVos because he came up with that idea at Buford Highway and Jimmy Carter because of a railroad constraint. So yeah, it was interesting when we ran the numbers at that location, realized that it doesn't give you that benefit. One thing that I always look at kind of initially at these alternative intersections is where are your highest movements? Where are your highest lefts or rights? And what should you look at to address those high movements?
Yeah, I'll go that side and come back here. Justin?
This maybe could work for GDOT, but just in terms of public outreach, so I'm thinking like there's. But two innovative things that we may not be used to, reaching out to them and kind of. How it's supposed to work. And how the process works. Yeah.
Public outreach, especially in terms of alternative intersection design, especially when it's the first of its kind, is extremely important. And there's been a lot of lessons learned through the years. And we actually, so a PIOH, where traditionally a lot of that's done in concept, there's a wide variety of ways. It used to be handing out pamphlets or amongst that community or knocking on doors. Through, and I think this was really being set up before the pandemic even started, but more of those virtual PIOHs to get more interaction with people, the ability so you don't have to get off work early, or even if we're off work late, people have kids and stuff, and so it's harder. That virtual element allows you to get that engagement, especially because it's left open so you can provide comments, and that's another big plus in my mind to be able to get that interaction. It also allows us to be able to put up visual representation. It could be a traffic model if it's not been built yet, or it could be a video of somewhere it's already there. And so that really makes the public feel a lot more comfortable in that. Another thing, especially that we have really emphasized, at least in my program, is how do we outreach to the community even before we even get to concept? Can I start having conversations when I draw up a conceptual layout in a TE study or whatever the case may be? We found that to be a good measure, especially when we're doing something we feel like could be controversial. So.
Thank you, Sam. Yeah. Yeah.
It's the engineers for Christian Smith for the outreach. We actually had a educational. Right before it opened. So we started group, model. Hands-on. 4 weeks before.
Oh, that's great. Yeah, another powerful thing is social media can be used in good ways as well. So you actually see our communications office really engaging with the public on these different alternatives and being creative in the PIOH. I've been to one where it's a roundabout and it may be in a county, but people aren't really understanding of what exactly a roundabout is, and they think it's the death circle. And so when they actually come in, we actually have drawn out with tape and put in the center of the room all the layouts and make them maneuver as they would in a roundabout. And they were doing that without even really acknowledging that they were being kind of herded into this area and producing like a roundabout. We try to be, crafty like that, but that also has really helped, because once we unveiled it, it's like, well, how does this even work? Well, how did you get from the door to this table? And they're like, oh, okay, yeah, I understand it now. So
That's great. I think we have 2 people. Yes.
And the DLT, it seems like they're all after the fact and ends up with business damages. Right away, like we do with roundabouts now, we build them way in back. Is there any way to predict on DLTs, like, let's get it in before all the development? Maybe that's for you.
I mean, that would be ideal, right? To be ahead of those heavy volumes coming. So I think, I guess I think what you all have seen from this presentation is this just a big consideration that everyone needs to have in terms of recommending a displaced left is what properties are you what access are you impacting? There are some ways you can do other things to help improve access to those properties. But it's just it's a consideration in that alternative.
I'll just add, over the past 5 years, you've seen more tools at our disposal that we couldn't even dreamed of. So take advantage of that, and you can try to be more predictive in nature. You can use that data to start building models and understand how traffic could behave, not like a huge travel demand model, but I mean, use the tools such as ATSPM. If you don't know what it is, it's free out there. You can pull up any signal on our network and get every 1/10 of a second, we have data that's logging onto a server and you can pull up information. Ridis, if you don't know what that is, another great application that can derive congestion costs, rank your bottlenecks, and pull travel time information, speed information. That's all stored and is available to our consulting communities when they're working on our projects, and available to any of our local stakeholders for free. And then we've already talked about Numetric a lot today, but that's another piece of the puzzle and utilizing this. But it's just using that data to try to understand what is the needs in the future. It's a little bit tricky right now because we're on a big forefront. You've heard the big data buzzwords that go around. I mean, we have so much data at our disposal now. We're trying to figure out how to use it. And I think one of the best ways to use that is to try to be more predictive in nature, especially with the forefront of connected vehicles and autonomous vehicles. That if no one's seen those data sets, you're talking about millions and millions of data points. That has tremendous opportunity.
Thank you, guys. Another question? Yeah.
This is about the first presentation. How much, as far as the toolbox for speed reduction, say road diets or travel is currently out there? I mean, the whole aspect that is out there of clearer, straighter, safer, and that also means clearer, straighter, faster. So is there a pretty wide toolbox for basically 10-foot length or 11-foot length instead of 12-foot length on a regular basis?
Yeah, no, it's a great question. So in terms of looking at roadways, state-owned roadways, I think a lot of that perception and thought process all the way up to our commissioner has evolved over time. And that for the positive on it. We as a safety team were tasked not long ago to evaluate every state route within the Beltline to determine what we could change. What are our opportunities in terms of changing the context of roadways that they fit all users? And that's something that came from our commissioner down to our department head and to us. So there are several projects just based off that one study that are going in and doing road diets, putting in speed countermeasures, speed reduction countermeasures to slow people down. And because over the pandemic, it's gotten worse, to be quite honest with you. When I review the fatalities of each year, the common trend I saw over the past 2 years is speed and distracted driving and driving under the influence. But speed really is. When our roadways opened up and people were less traveling on them, drivers took that as, well, there's more room for me to do what I need to do, what's comfortable. And we saw those speed increases. Now, it sounds weird, but the safety program is okay with a little bit of congestion because it slows people down. But in principle, like I said, it's evolved in nature. There are a lot of roadways that we are looking at from the DOT's perspective, in particular the safety program, is how do we change the context of this roadway? Is it used the same way that it was originally used? If the answer is no, then let's build a good project off of that. That benefits everybody. So hopefully I answered your full question. But.
All right, thank you. Another question? Yeah, in the back.
So for Georgia, we do not. We don't have any safety performance functions quite yet. We are very ambitious in that area. That is something that we were actually working with Numetric now to automate that process. There are some states that have 80+ safety performance functions, and I take that as a goal for our state. So you're going to see those come out, those start to roll out in the next year or so to be able to validate what's happening on Georgia roadways So we can put those into the crash modification inventory to be able to use. But we have looked at before and after studies, it just hasn't gone through that full step of making it any type of crash modification factor.
All right, one more question? Yeah.
This was for Andrew. Routes that are up to DFI changes in Dade County and where else?
Douglas County. Yes.
Any other questions? Oh, thank you for all the great questions. I do have one question for Sam and Kelly. And new metric, as you guys mentioned, it's really a game changer. And I know you guys are working to incorporate more data in the near future. Can you guys tell us a little bit more about for the benefit of the audience?
Yeah, no problem. And what time is it?
Yeah,
5:41.
yeah.
Y'all ask so
3
many
minutes.
questions that I only get the chance to pass out the test. So this is
Oh.
like back in college or high school. So now you've led the professor on, and I've rambled enough and got into my tangents that we don't have to give you it. So good job on y'all. There's lots of exciting things coming out, a new metric coming up really soon. I showed you on there that we can actually rank roadways based on filters and severity and crash indexes. We're actually about to unveil an intersection module to that. So we have a very extensive effort, but we've mapped out all the intersections in the state of Georgia, and you can rank those based on filters. And so that's going to be very exciting. I talked about the safety performance functions that'll be coming out soon. We're looking at building an API with Ridis to be able to start pulling in speed data into the tool, which again, we've highlighted why speed is so important, but that is something else that we're working towards. I feel like I might be, collision diagrams. So there's lots of different ways you can hand draw those, lots of different programs out there that can draw them out. But with a click of a button coming up in New Metric, you'll actually be able to get a collision diagram populated within the tool that you will be able to edit as a user to make your engineering judgments to say, well, when I read the crash report, this more seems like the pedestrian went to the hospital. It's definitely not a PDO. That's more of a serious injury. So I don't think that's an angle crash. I think that's a head-on crash. So you actually have the ability to change that, and you can actually print that out. It'll actually create a picture out of it that you could put in a report. And that's a really big game changer, I know, for a lot of people to be able to have that at their disposal. So thanks for the question.
Great. Thank you so much for the presentations and all the great answer questions. So just quick announcement. If you haven't signed up for the PDH sign-in sheet, I don't know where it is, please sign in the sheet. Who has the paper, please? Okay, right there. So in the back. So please sign in, and just quick announcement. I know we have a break until 6:30 and the dinner is at 6:30, and we will have a keynote speech then from Jenny Miller. So have some break and we'll get back to here for the big room for dinner 6:30. So thank you, everyone. Thank you.
Oh my gosh, no, I'm glad I just worked out. Thank you.
I'll go ahead and email.